Nice to meet you. I'm Khatar Chuktai and you're watching my YouTube channel, School of Advanced Chemistry. I'm going to explain Cambridge O-Level Chemistry Paper 2 Theory, May-June 2023 2-1 variant. Let's get started. 1 hour 40 minutes time period and total marks is equal to 80. Question number 1. Choose from the following oxides to answer the question. Al2O3, that is said to be aluminium oxide, CO carbon monoxide, CO2 carbon dioxide, CaO calcium oxide, Fe2O3 iron oxide, H2O water, Na2O sodium oxide, SO2 sulfur dioxide, SiO2 silicon dioxide. Each oxide may be used once, more than once, or not at all. State which oxide is a solid which made during the thermal decomposition of the limestone in the blast furnace. What is the limestone? Limestone is calcium carbonate. When it is heated in the blast furnace, it is going to make calcium oxide plus CO2. So this is the solid product and this is the gaseous one. So the solid that is made during the thermal decomposition is calcium oxide. B reacts with both acid and alkali, I mean any amphoteric oxide. So aluminium oxide and zinc oxide, lead oxide, etc. They are said to be the amphoteric. Here this is the aluminium oxide and aluminium oxide is an amphoteric. Has a joint covalent structure. Joint covalent structure is for diamond, for graphite, for SiO2 in your syllabus, in O-level syllabus. So SiO2. Has an ion with oxidation number of +2. So it must be group 2 element, group 2, group 2, group 2, group 2, group calcium oxide. It's having calcium oxide. This calcium is having +2 oxidation state. Turns white anhydrous copper to fade blue. This is the property of water which turns anhydrous, mean there is no water. Anhydrous copper sulfate is white and water turns it blue, H2O. F, the last one is, which one oxide is made during the fermentation of glucose to make ethanol? Ethanol plus CO2 is formed, carbon dioxide, and yes, that is also in the list given over here, and this one, CO2. Question number 2. Group 1 includes the element lithium, sodium, potassium, and so on. State 2 physical properties of lithium. Physical properties mean basically you will write about melting point or boiling point and electrical conductivity, and ductility. As far as the physical properties of the metals are concerned, and malleability are usually malleables. Malleability, density, etc. So basically, in case of metal, you will have to choose melting point, electrical conductivity, ductility, malleability, density, and so on. Lithium is a group 1 element and group 1 element having low melting point. They are said to be having low melting point. Second one, they are ductile. Yes. They are malleable. Yes, it is true. Potassium react with the cold water. The ionic equation for the reaction is shown over here. Potassium plus water goes to potassium positive ion plus OH negative ion plus hydrogen. State in terms of electrons why potassium is a reducing agent in this reaction. In terms of electrons, what has happened to the potassium? Initially, it was having zero oxidation state, and now it is having +1. So it means that it has lost one electron. I mean, potassium loses an electron, or each potassium, you can say, each potassium loses an electron. So that's why it is said to be a reducing agent. State oxidation number of the hydrogen in hydrogen. H2. It's a pure element. It is having zero oxidation state. So it is having zero oxidation state. Describe what is observed during this reaction. Observation. Come toward the main equation. It's a gray solid, colorless liquid, colorless ions, hydrogen gas is going to be formed. And this is basically the member of group 1 element. So number 1, you can say, you can write over here that potassium, or it floats, a potassium float or potassium floats randomly on surface of water. And catch fire. So the first one is potassium float randomly on the surface of water and catches fire. And as there is the formation of hydrogen gas, effervescence is observed. Effervescence is observed. And as it catches fire, you can write the color of flame as potassium. So lilac color flame is over here. And as I told you initially, solid dissolve, solid disappear, and so on. Gray solid melts or dissolve. And so on. So for 1 mark, for 1 mark, for 1 mark. And for catches fire, again, I think for 4th mark as well. A sample of sodium chloride is tested using a flame test. State the color of the flame seen in this test. As you are using sodium, so because of sodium, yellow flame. The color of test will be yellow. Question number 3. This question is about the preparation of salts. Zinc chloride is a soluble salt. It is prepared by the reaction of an insoluble base with a dilute acid. The equation for this reaction is shown over here. Zinc oxide plus 2 mole of HCl goes to zinc chloride plus H2O liquid. A sample of 3.5 gram of zinc oxide is added to 50 centimeter cube of 1.2 mole per dm cube hydrochloric acid. Show by the calculation that zinc oxide is in excess. First of all, you need to find the mole of these both species. Zinc oxide, what is the MR of zinc oxide? Zinc 65 plus 16 is the mass of oxygen. Overall mass is equal to 81 gram. And the mole of zinc oxide from 3.5 gram I mean mass over mr. 3.50 divided by 81, and the answer is 0.0432. That is the mole of ZNO used. Now come towards HCl. How to find the mole of HCl? 50 multiplied by 1.2 divided by 1000. That is equal to 0.060 moles of HCl. Moles of HCl. The next one is, from the balanced chemical equation, you can see that HCl versus ZNO. 2 mole of HCl is equal to 1 mole of ZNO. 2 moles of HCl is equal to 1 mole of ZNO. And now at the moment we are using 0.06. Then what about the mole of ZNO? It will be equal to 1 by 2 into 0.06. I mean that is equal to 0.03 mole will be used. So that is the quantity of the ZNO that is going to be used in this case, and total mole of zinc oxide is this one. Total moles of ZNO. Is equal to 0.0432, and this mole used. So used is equal to 0.0300. Remaining mole will be almost 0.0132. That is, so zinc oxide is in excess, and so on. Come toward the next portion, state why it is important to use excess zinc oxide. Excess zinc oxide, I mean, it is used to ensure the completion of reaction. Or to use all the acid present. To use all the acid present in the mixture. Suggest how zinc oxide is removed from the reaction mixture to leave only aqueous zinc chloride. As you know, it's a solid, so we will use the method of filtration. Filtration is the method to separate any solid from the liquid or from the solution. Barium sulfate is an insoluble salt. It is prepared using precipitation reaction. Name 2 aqueous solutions that react together to give barium sulfate. Barium sulfate, so this portion is basically positive and this is negative. So barium nitrate, all metal nitrate are water soluble, I mean. So the barium nitrate, it's saying the name. So I'm going to write the name, not the formula. Barium nitrate All nitrate are water soluble. The next one here is SO4 2 negative ion. So you can use acid, you can use sodium sulfate. I am writing sulfuric acid. Sulfuric acid. Part C, sodium nitrate is a soluble salt. It is prepared by the reaction of an acid and alkali. Name the acid and alkali. Sodium nitrate. The metal is the part of alkali. Metal is always the part of an alkali in a salt. So sodium hydroxide is alkali. Sodium hydroxide. Nitrate ion, what is the acid of nitrate ion? Obviously HNO3, nitric acid. Nitric acid. Next part, name the experimental technique used to make neutral aqueous sodium nitrate, as one is alkali, other one is acid. So there is only one way out, only one technique, that is said to be titration, to make a soluble salt using acid and alkali. Part B, state why the formula of phosphide ion is P3 negative ion rather than P2 negative and P4. Basically, phosphorus is the member of group 5 element. It is having 5 outermost electron. It is having 5 outermost electron. So it needs 3 electron to complete its octet. It needs 3 electron to make its full octet. So it needs 3 electrons to complete its octet or outermost shell. See, the formula of calcium ion is calcium 2 positive. Deduce the formula of calcium phosphide. Ca2 positive, P is having 3 negative, negative positive will be cancelled out, 3 over here, 2 over here. So the formula is Ca3 and P2. P2. Calcium phosphate is an ionic compound. Explain why the calcium phosphate has high melting point. So in melting point, especially in high melting point, we will discuss the bonding and structure. First of all, we will write that calcium phosphate is having joint structure, and strong ionic bonds. And strong ionic bonds, strong electrostatic force of attraction, ionic bonds. Hence, more heat is required to separate ion. These ions. Calculate the percentage by mass of phosphorus in calcium phosphate. So first of all, you need to know the formula mass of calcium phosphate. Ca3PO4 twice. Calcium is equal to 40. AR of calcium is equal to 40. Calcium of phosphorus is equal to 31. And calcium of oxygen is equal to 16. So 3 into 40 plus 2 phosphorus, 2 into 31 plus 2 fours are 8 oxygen, 8 into 16, and here is the MR of calcium phosphate. Let me check the MR. 3 multiplied by 40 plus 2 multiplied by 31 plus 8 multiplied by 16. The answer is 310. It's MR. It's formula mass. So what is the percentage by mass of phosphorus? What is the phosphorus in this compound? That is 2 into 31, 62. So 62 divided by 310 multiplied by 100. So 62 divided by 310 multiplied by 100, and answer is 20%. 20% is the answer. Now come toward the next one. Question number 5. Ammonium chloride decomposes when heated to make hydrogen chloride and ammonia. This reaction is reversible. The forward reaction absorbs thermal energy. Forward reaction absorb thermal energy. So heat is being absorbed over here. That is an endothermic reaction. An equilibrium mixture is formed when reversible reaction happens in a closed system. State what is meant by the term equilibrium. Include idea about rate of the reaction and concentration of the reactants and the product in your answer. Mark of the question is equal to 2. So I'm going to write basically the basic definition of equilibrium. Equilibrium is a stage at which a rate of forward reaction becomes equal to the rate of reverse reaction, a rate of backward or reverse reaction. So the stage at which rate of forward reaction in terms of rate become equal to the rate of forward reaction, rate of backward reaction, this stage is said to be equilibrium, and sometimes you can call it dynamic equilibrium. The next one thing is, what about the concentration of the reactant and the product basically. Concentration of reactants and products become constant. at this stage. At this stage, constant at this stage. So these are the basic 2 points for 2 marks. Next one, predict what happens to the position of equilibrium when temperature is increased and pressure remains constant. Now you can see that this overall reaction is endothermic, and you are going to increase the temperature. So increase in temperature favor the endothermic side. The forward side is endothermic. So basically equilibrium will be shifted towards right hand side. This is the right hand side of the equation. Right hand side, this is the left hand side of the equation of the reaction, you can say. So equilibrium will be shifted. Prediction mean equilibrium will move towards right. Position of equilibrium will be shifted to right hand side or right side and so on. Explanation number 1, reaction is endothermic. Forward reaction is an endothermic, right? This is the basic thing. And increase in temperature favors endothermic side of the reaction. To minimize the heat. The next one, predict what happened to the position of equilibrium when the pressure is increased and the temperature remains constant. At constant temperature, he or she is going to increase the pressure. In case of pressure or for the effect of pressure, we will have to check the number of moles of the gases. So the number of mole, 1 mole over here, 1 mole over here, no mole of the gas was lying on left hand side. So 2 moles on the right hand side and no moles on the left hand side. So on increasing the pressure, equilibrium will be shifted toward that side where there are less number of mole or no moles. So position of equilibrium will be shifted. Position of equilibrium will be shifted towards left hand side, or towards left, Explanation, there are no moles of gases. There are on left hand side, there are no moles of gases, or less or no moles of gases. Increase in pressure favor the side of less mole. The side of less number of moles. Of moles. So that is an appropriate answer. Part B, predict what happened to the rate of backward reaction when temperatures increased and pressure remains constant. Now, this time he is or she is asking about the rate of reaction. So, temperature increase, rate will be definitely increase. On increasing the temperature, the rate of forward reaction increases and rate of backward reaction also increases. So simply speaking, rate will be increased. Rate will be increased. What's the reason behind it? The reason is basically number one, more kinetic energy of the particle will be there. Our particles move faster. Our particles have more kinetic energy. The next thing is, for the more marks, you can say there are more number of effective collision more number of effective collisions. More number of effective collisions per unit time. And third one, that is also the appropriate one, more particles are having energy. More particles are having energy greater than energy of activation. Energy of activation. Hence, there will be the more rate of reaction. C part, what happened to the rate of backward reaction when pressure is increased at a constant temperature? Explain your answer. Once again, pressure is also having the direct relationship with the rate of reaction. Higher the pressure, higher the rate of reaction for both. I mean, by increasing the pressure, rate of forward reaction increases. Also, there is increase in the backward reaction of the reaction. So both rates, forward and backward, increases if we are going to increase the pressure. So the prediction is rate will be increased. Rate will be higher. In case of pressure, why the rate is higher? Pressure is inversely proportional to the volume. So higher the pressure, smaller the volume. And then more particles per unit volume. More particles are there per unit volume. And so more number of effective collision per unit volume, per unit time. more number of effective collagen per unit time. So ultimately rate is the higher. Question number 6. This question is about energy changes that takes place during the reaction, chemical reaction. Methane reacts with chlorine to make chloromethane. This reaction is exothermic. CH4 plus Cl2 goes to CH3Cl and HCl. Draw on the axis provided in figure 6.1 the reaction pathway diagram for this reaction. Include a label for the axis, reactant products, enthalpy change of the reaction, that is delta H, and energy of activation. So first of all, I am going to label the axis. And here is enthalpy or energy. Energy or enthalpy, and here is the progress of reaction or reaction pathway. Reaction pathway. Now I'm going to mark a line of the reactants. A supposed mark of the reactant. Reactant have to gain energy to cross the barrier, that is said to be energy of activation. And as the reaction is exothermic, so the final energy of the product will be less than that of the reactants. Energy required to the reactant to make activated complex or this high is said to be energy of activation, and energy change, enthalpy change, energy change between reactant and the product is said to be the delta H. So this is delta H, this is energy of activation, and reactant, products, energy, reaction pathway, and so on. I think you should mark the solid line over here. Okay. Wow, it was 5 marks question. Hydrogen iodide decomposes to make hydrogen and iodine. Calculate enthalpy change for this reaction. Table is given over here. You know what is the formula of enthalpy change whenever you are going to use the bond energy data. Here are the bond energy data, and that is the bond energy of reactant minus bond energy of the product. So what is the bond energy of the reactant? Basically 2N2HI, these are the reactants, minus H bond energy plus I bond energy. So 2N2HI, its answer is 298, 2N2 298 minus H bond energy is equal to 436 plus you can call it small brackets I bond energy, that is 151, and so on. So that is equal to 596 minus this sum is equal to 587, and overall answer, the final answer, is equal to plus 9. Plus, it is necessary to show the sign, this one, plus 9 kilojoules per mole. Question number 7. Methanol, propane 1-ol, propane 2-ol are alcohols. Display formulae of methanol, propane 1-ol are shown in figure 7.1. methanol, propanol. State the general formula of homologous series of alcohol. The general formula of the homologous series is very much simple. I mean, it is an alkane plus formula of alkane plus oxygen. You know what is the formula of alkane? That is CnH2n plus 2O. Or you can write in this way. I mean, I'm shifting one H over here. So the second one possible formula CnH2n plus 1, and then we will write OH over here. Come towards propane 1-ol, propane 2-ol have the same molecular formula but different structure formula. State the name given to the compound that have same molecular formula but different structure formulae. These sort of compound are said to be isomers of each other. So the basic name is isomers or structural isomers. So it is, I think it's more good, or it is more wise to write the proper form of isomerism, but it's a structural isomerism. Draw the structure of formula of propane 2-ol. Prop mean 3 carbons are over here, ane mean all single bond, 2 is the position, ol mean OH group. So 3 carbons are over here, and the second carbon number 2 is having OH group, and so on. Rest of all carbon are having hydrogen. I mean, I'm going to fulfill their valency, and here it is propane 2-ol. State why propane 1-ol is a saturated compound. What are the saturated compound? Compound having all carbon single bond, because it is having all carbon single bond. That's why it is said to be the saturated. Explain why propane 1-ol is not a hydrocarbon. It contains oxygen atom. Or you can say atoms, and or as well as carbon and hydrogen atom. So atoms. So it is not having only carbon and hydrogen atom. It is not having only carbon and hydrogen atom. It is also having oxygen atom. That's why it is not a hydrocarbon. It is a derivative of hydrocarbon. Propane 1-ol react in the same way as ethanol. Propane 1-ol reacts in the same way as ethanol. Display the formula of the product of the reaction of propane 1-ol with acidified potassium magnate. Basically, it is an oxidizing agent and it will oxidize the alcohol. Propane 1-ol, this is the formula of propane 1-ol. This is the displayed formula of propane 1-ol. And upon the addition of KMnO4, that is oxidizing agent, this carbon will be changed into the acidic carbon. I mean, the carbon that is having OH group, it will be changed, it will be under attack, it will be under oxidation, and it will be changed into carboxylic group. So there is a removal of 2 hydrogen, then introduction of 1 oxygen. Removal of hydrogen is oxidation, introduction of oxygen is also oxidation. So the finally, basically, this is the formula of final product of propane 1-ol oxidation. Next one, draw a displayed formula of the product reaction of propane 1-ol with ethanoic acid in the presence of a catalyst. So propane 1-ol, if it is allowed to react with the ethanoic acid, then it's going to make an ester. Catalyst is obviously an acid. So propanol, I'm going to write 3 carbons, OH group, and here I'm going to write carboxylic acid, that is having 2 carbon, eth mean 2 carbon, ethanoic acid. In this way, or in this case, basically, is losing OH group and it is losing H group. So they are meeting together to make an ester. So they are meeting together to make an ester. I mean oxygen, oxygen, oxygen and carbon will be linked together, and thus this is the ester. So C double bond O, I'm going to write it again over here, then O, then C, H, 2, C, H, so CH3 over here. So finally, that is propyl ethanoate. It is propyl ethanoate. F. Methanol is a covalent substance. Draw a dot and cross diagram to show the bonding in molecule of methanol include only the outer shell electrons of each atom. So dot and cross diagram for methanol. First of all, I am going to write the displayed formula of methanol. Let's see over here. Methanol. This is the displayed formula of 1 carbon alcohol, that is said to be methanol. So in this case, now I'm going to draw the dot and cross. Let's suppose I'm going to give a dot for the carbon electrons and oxygen for cross and hydrogen cross, you can say. So dot, cross, dot, cross, dot, cross, dot, cross, and cross over here. I will have to put dot to differentiate between the electron of oxygen and hydrogen. So the finally carbon dot and cross hydrogen, dot and cross hydrogen, dot and cross hydrogen, dot and cross oxygen, again dot and cross for hydrogen. And now the oxygen atom is also having 4 more electrons. It has been used 2 electrons over here, but it is having 4 more electron as it is the member of group 6 element. So 4 crosses will be there, I mean 2 lone pair on the oxygen atom, and that is the true dot and cross diagram of methanol. Said why methanol does not conduct electricity, because it is not having any sort of free electrons. Electrons cannot be moved. It does not have free electrons or mobile electrons. You can see all electrons are bonded, not free. All electrons are bonded. Electrons are not free, right? It doesn't have any free electron or electrons. Or, the second one option is you can write all electrons are bonded. Methanol is used as solvent. State the meaning of the term solvent. Usually a liquid, it may be or it may not be the liquid. Usually a liquid, in this case you can write liquid that dissolves solutes in it. Solutes in it is said to be a solvent. Question number 8. This question is about electrolysis. The table shows some information about the electrolysis of the 3 different electrolytes using graphite electrode. The electrodes are in it. Complete table 8.1 with the name of the product at each electrode. Electrolyte, dilute aqueous potassium chloride. Second one, aqueous copper 2 sulfate, molten lead 2 iodide. What is happening at anode and what is the product at cathode? Anode is a positive terminal in this case, cathode is a negative terminal in this case. Dilute potassium chloride. In case of dilute, OH ion is the winner ion in the solution. Our water molecules are the winner, and so they are going to make oxygen. They are going to make oxygen at anode. Again, in case of dilute, potassium ion is not enough stronger. Potassium ions are not the winner ion. H positive ion is the winner ion, so hydrogen gas will be formed. H2 gas will be formed, oxygen gas and hydrogen gas. In case of aqueous copper 2 sulfate, copper ions are more active ions than hydrogen ions. So here will be the copper solid. They will go and receive the electron and make the copper metal. In case of sulfate ions are less stronger negative ions as compared to the OH negative ion. Then again oxygen gas will be over here. OH negative ion will migrate towards anode and O2, oxygen is being formed. In case of molten, only 2 type of ions are there. Lead 2 positive, only one type of positive ion, lead 2 ions, and I negative ions are there. So iodide ions will move towards anode to make iodine, I2, and it may be in form of a gas, it may be in form of putting gas over here because it's molten, and here will be Pb, it will be in form of a liquid, Pb, lead, and so on. B. Electrolysis of the aqueous copper 2 sulfate gives different products with the copper electrode are used instead of graphite. So this time we are using copper electrode. These are non-inert electrode instead of graphite. Graphites were inert electrode. So in case of non-inert electrode, these are called non-inert electrode. Non-inert electrode. So in case of non-inert electrode, anode is dissolved. In this case, anode will be dissolved. Electrolyte's composition will remain same. These are the 2 basic main reason. Cathode is going to have copper, that is a pinkish brown solid. So number 1, anode will be dissolved. Anode will be dissolved. or it will lose its mass and so on. Second one, electrolyte will remain unchanged. Electrolyte will remain unchanged. Number three, electrolyte will remain unchanged, or blue you can say as it is. The third one is pinkish brown solid will appear. Pinkish brown solid will appear at cathode. Come toward the next one. Magnesium is manufactured by electrolysis of the molten magnesium chloride at the anode. Chloride ions react to make chlorine molecules. Construct the ionic half equation for this reaction. So 2 mole of Cl negative ions go towards the anode. They loses 2 mole of electron and make 1 mole of Cl2 gas. So this is the perfect ionic equation. We will write liquid for state symbols in case of molten and so on. Question number 9. Oxide of the nitrogen such as nitrogen monoxide, NO, or atmospheric pollutants. The exhaust gas from the car engine contain 0.00200% by the volume of nitrogen monoxide. Calculate the number of molecules of nitrogen monoxide in 960 dm cube of the exhaust gases at room temperature and pressure. 1 mole of any gas contains 6.02 into 10 to the 23 molecules. So the total exhausts are equal to 960 dm cube. And you know the percentage of nitrogen monoxide is this one. So what is the volume of nitrogen monoxide? First of all, volume of NO, nitrogen monoxide, will be 0.002% of 960 and that is equal to 0.0192. That is the dm cube. And we know at RTP 24,000 centimeter cube or 24 dm cube is equal to 1 mole. We are having volume in dm cube, so 24 dm cube is equal to 1 mole, and 0.0192 will be equal to how much moles? I mean, if we want to find the number of molecules, then we will have to find the mole first. Whenever you are asked to find the number of molecule, number of atom, number of ions, then simply speaking, you will have to find the moles. You will have to find the mole first. So x and x will be equal to 1 over 24 multiplied by 0.0192, and the overall answer is 0.0008. So these are called moles. 1 mole is equal to Avogadro's number, 6.02 into 10 to the power 23 molecules, and for this mole 6.02 into 10 to the power 23 multiplied by 0.0008 moles finally will be equal to 4.816 into 10 to the power 20. So that is the number of molecule of nitrogen monoxide. Nitrogen and oxygen react to make nitrogen monoxide inside the car. Construct the equation for this reaction. Nitrogen N2, oxygen O2 goes to making NO. To balance this equation, 2 mole of NO. State one adverse effect of oxide of nitrogen on the pollutant gases in air. Number one, they causes acidic rain, or the oxide of the nitrogen make photochemical smoke. Photochemical smoke. Photochemical smoke. Describe how oxide of nitrogen formed in the car engine are removed by the catalytic converter. Yes, basically, uh, they react with carbon monoxide and they react with unburned hydrocarbon. Uh, these react with carbon monoxide and unburned hydrocarbons and change into nitrogen and nitrogen gas, change into nitrogen gas. Rate of diffusion of the nitrogen dioxide is less than that of nitrogen monoxide. Under same condition of the temperature and pressure, explain why the rate of diffusion of the nitrogen dioxide is less than that of NO2. The mass of NO2, MR of NO2 is equal to 14 plus 32, 46, while the mass of NO is equal to 14 plus 16, that is equal to 28. So its mass is higher. NO2 is having higher mass, so its speed of diffusion will be slow. NO2 having higher mass. Higher mass or more density, roughly speaking. Higher relative molecular mass. So its rate of diffusion is slow or less. Rate of diffusion of the nitrogen monoxide decreases as the temperature decreases. So just by using idea about the kinetic particle theory, why the rate of diffusion is going to decrease with the temperature. The basic thing is the temperature mean kinetic energy. So particles are having less kinetic energy. Particles have less kinetic energy. So that is why at low temperature, that's why it is having less rate of diffusion. PVC and polypropylene are the polymer made by the reaction called addition polymerization. Diagram 10.1 shows the structure of PVC. Draw the structure of monomer used to make PVC and monomer. There is the simplest way. Just reverse this continuous line or continuity line of continuation. It will be shifted over here, it will be over here, it will be over here, and it will be waved off. So you can see that here is the double bond, no bond, one molecule, same as the case, double bond, no bond, double bond, no bond. So this is the second molecule, and double bond, no bond, this is the third molecule. And all monomers are same. So carbon single bond, and Cl over here, H over here, H over here and H over here and double bond over here. Polypropylene is a polymer used to make plastic food container. Show the structure of polypropylene. 10.2. Some waste polypropylene plastic is disposed of by burning. This makes toxic gases because of incomplete combustion. Name the toxic gas. Name the toxic gas, that is carbon monoxide. Carbon monoxide. On burning, it may be produced. State one other environmental challenge caused by the disposal of waste polypropylene plastic. Explain how this challenge is related to the properties of the polypropylene. Environmental challenge. This challenge may be the accumulation of the plastic in oceans or landfills. Landfills or accumulation of plastic in sewage or in ocean. Plastic in ocean. And basically these are chemically unreactive. They are not dissolved in water. Insoluble in water, insoluble in water, and do not react with water, no chemical reaction with water. Showing no chemical reaction. With water. No physical, no chemical reaction in water with water of this polypropylene. Name the condensation polymer. Draw the structure formula of the linkage between the repeating unit in this polymer. Name and linkage. So there are 3-4 condensation polymers. Name number, for example, polyester. Linkage. The polyester is having O. Ester linkage, O, C, double bond, O. That is having an ester linkage, and it is having repeatedly. So it may be the polyester, it may be the polyamide, and it may be the protein as well, and so on. So that's all about this paper. Thank you very much, and please subscribe my channel, hit the bell icon, and share it with your friend. Thank you very much. Have a nice day.